All righty. I think we're about 2 weeks, maybe 3 into the semester. Hard to know. I'm making these videos before I've even met you. But I hope we've kept up with word of the day. Let me get things going. All right, so we'll do that to start off the video. Let's see if you remember. And as I say, I'm hoping we keep up with this, but this may not have any meaning at the moment. E, you remember what it means? Esoteric, right? This process is perhaps an esoteric event. There's only a bunch of us know what we're doing here. V, vacuous, empty, lacking content, stupid. Another E, enervate, weaken, kryptonite, certainly enervated, supervated. R, restive, impatient, stubborn. So it might be an adolescent giving you a little hard time. Y, yoke, I think that's what it's called, with the oxens are yoked together. That wouldn't, little for the heads and whatever. So yoke is to tie together. Ribbled, kind of coarse, crude, humor. E, effulgent. I picked E today, effulgent, because I didn't know what it meant. And it's kind of splendid. And so effulgent smile. I think the example on your worksheets is the splendor of the palace, the effulgent nature of something. All right. So brakes are on. Got enough new stuff in front of us. Time for you to get a little time to strengthen your foundation. First stage of learning is following, and maybe that's quite a bit of what you've been doing. Hopefully we've had one little scrimmage and followed 2 days later with another attempt at it. What I generally see is about, from a 2-day situation like that, about 3 or 4 more right answers than the previous test. And it's really all about your learning rate. What rate are you learning? The biggest jump I'd ever seen was after 2 weeks of algebra 2 and 1 review in a pre-cal class, which student only got 4 right, which is kind of a disappointing situation considering the problems. 90% of what I was asking was review, but 2 days later he had 44 right. That's a bigger jump than I've ever seen. 40 more right answers in 2 days. So obviously he gave this work some mindfulness and really looked at what I was going to ask him. He went after it. So he's an engineer, which is nice to hear. All right, so much of what we've done is thus far has been built on rectangles. But if you draw a diagonal, okay, so this is some new material for you. If you draw a diagonal, you've actually created a triangle. So I'll highlight the triangle. All right, and if you put the triangle in a coordinate system, and remember, triangles have a nice little Pythagorean relationship to them. Right, so if you make this side smaller, and this one's got to get bigger. And what really happens is you end up with this circular rotation. And so if this one gets smaller, then this one has to get bigger. There's the smaller one, there's the bigger one, but the radius is a constant. All right, so that's something to think about. I need an eraser here. You're right back. So what came out of this evolution of rectangles to squares, to triangles, to cubes? Well, study trigonometry, study of triangles. And so there's just 3 commands that I want you to think of. And we'll work with a 3, 4, 5 triangle. I think that's the most familiar one. And here's an angle here. And we can easily find that angle. It's stored in the computer banks, because the ratios produce particular angles. And so I'll just write the 3 things that I'm hoping you learn. Sine of angle A equals 4/5. The cosine of angle A equals 3/5. And the tangent of angle A equals 4/3. So I must know what I'm supposed to be looking for. And the sine is really the opposite side of the angle compared to the hypotenuse. And that is called a ratio. Right, so that's the side that's opposite the angle, and you divide it by the hypotenuse, and you got a calculation. Cosine is the adjacent. Here's the drawn in standard position, attaching the angle to the origin. This is the adjacent side, the side next to the origin. Right, so adjacent over hypotenuse is the language being given to you by COS, cosine. Tangent, the opposite side divided by the adjacent side. Okay, so let's just draw a triangle. There's an angle, there's the opposite side, there's the adjacent side, there's the hypotenuse. And you're going to do 3 problems like this later in the worksheet. We'll get to it. All right. Remember, the brakes are on after today. We'll just stay put with the problems that we got in front of us for a good week or so. Get you feeling a little better about what you're looking at. I think I've got a cloudy lens here. See if that helped. Could be my eyesight. Who knows? All right. Lost my eraser. Let's pick that up. And now we'll do the worksheet together and not spend too much time on the problems that we've been doing quite a bit. All right, so what do I see? I see -5, critical number, because this is a product. That's a product, and best thing you can do with products is make one of the factors 0. So make -5 makes that a 0. Changing by 7, 2, 9. 4 is what I get when I cancel out that product with a -5, and I'm changing by down 1, 3, 2. So now I'm going to replace 9, 2. I'm pretending I'm on an exam. I'm going to put 9 in and see if it's true or false. 9 plus 5 is 14. 7 goes into 14 twice. -1 times 2 is -2. And -2 plus 4 is 2. I know I got 1 right on my test. Yay. Now we're going to take this and write it in slope intercept form. I shouldn't have done what I just did, because now I got to remember what I wrote. From -5, 4, I can create it. And I'm changing by 7. I'm going down 1. Well, that was easy enough. Okay. But this gets pushed so much in algebra 1. And we're not doing that because it tends to cause trouble later on in your high school careers, because you develop a linear mindset. We're trying to get rid of that as much as possible. So because it's stressed so much, it's useful to at least know how to put it in the mx plus b, but I'm not using m. I'm using a as the grade adjuster, right? And there's a grade adjuster with a quadratic, there's a grade adjuster with a cubic, and we want to understand where that letter a, that coefficient, comes from. Let's not erase it too well. I'll give it the squirt later. All right, so how do we get this thing? Well, we got to get rid of the parentheses. So -1/7 gets multiplied times x. It also gets multiplied times 5. 5 of these things is going to be -5/7 plus 4. Okay, we got to get, I don't need 2 negatives here. Just talking. All right, so -1/7 gets us that, and -1/7 times 5 gets us that. And then hopefully intuitively, you can see how to get 28/7, which is another way of writing the number 4. So your final answer, -1/7 x, take away 5 from 28, and you get 23/7. Now, if you're making sign errors, you might want to start putting some things together here. Put 0, put -5, put 28. All right, maybe you can take the 5 away from that, but number line sometimes can help students who have trouble with negative signs, because that'll absolutely cause you trouble as you go through your high school career. You've got to sort out the rules around negative numbers. All right, so now we're writing equation of the line. I'm just going to deal with the x part, x minus 2023. And what did I do to get to 2123? 100 years. All right. I want 8 pi to come out of this. I know if I put 2023 in, this product becomes 0. I got a marker. I can make the correlation where that now gets me that for a y value when I drop 2023 in. Hopefully you're seeing that more clearly. And how do you get from pi to 8 pi, 7 pi? And I'm wondering if we stop class to talk about what pi equals. Where's that 3.14 come from? And that's probably something that we should do. Maybe this will take 2 days on the worksheet because that's a conversation you have to have. All right, so next. Now you hit the space bar or you just follow it, your choice. I asked you to sketch this. Well, the first thing you want to do is to sketch minus 2/3 x minus 6 equals y. You put numbers in, you get numbers out. This is a product. So what's the easiest number to put in place of the letter x? 0. So we can see that 0 gets us -6. And might as well go down 2 and over 3. If I go down 2, I'm at -8. And if I go over 3 from 0, I'm at 3. So this is the number 3 here. And that's another point. So it looks like it does that. And I want to find out when I'm equal to -22. Oh, that's -6, -8. Oh my God, -22 is off the board. I'm not going to put an ink spot down here, but I'm going to come back up and I'm going to go, okay, that's 3 units, 6, 9, 12, maybe around 15. I'm going to guess 15. If I'm in the ballpark around 15, I'll be happy with my guess. Let's see how close I am. So the first thing I'm going to do is I'm going to add 6 to that side. And so that's -16. Then I'm going to multiply that by 3. Well, that's -48. Then I'm going to divide that by -2. Okay, -2 makes that 24. Looks like I needed to be down a lot further. Oh, but I'm old. I couldn't have stretched that far. So I'm going to blame it on physical maladies. Too many orthopedic surgeries. All right. All right, same thing here. -5x minus y is in the mx plus b form. I could call that a from now on. So -5x minus 1, -1's the y-intercept, down at 5 to 1, something like that. And this one is 2x minus 4, so if that's -1, -4 is roughly there, ratio changed, call it that. 2x might look like that. We have an intersected x value here. That's pretty small. Yeah, 2, 3-ish. All right, so let's go find it. All right, so I'll bring the 5 that way and make it 7. I don't like dividing by negatives. I'll bring the 4 this way. That makes it 3. That makes more sense. I think 2, 3, it seems big. 3/7. Yeah, that actually fit the picture a little better. Should have been bold and said, oh, I think x is near a half. I didn't have the guts to say it. After the last one I butchered in terms of size. Having a tough day. I like better guesses than that. All right, so now let's get this desk over here. Shut the door. We're just doing a mechanical problem here. Now we got a quadratic cup shape down. It looks like 2 gets us a 5. And we got a little look-see there. So now you know the roots, by the way. You know the roots are 2 plus or minus the square root of where was I? 5. So 5, what? And minus divided by, so 3. Yeah, it would have been minus and minus, so that's good. Just having some fun. All right, so this is a +5, which means you want to view it in your mind's eye that way. You want to view that way. All right, so we're hopefully getting better at x squared minus 4x plus 4 plus 5. And we're doing -3x squared plus 12x minus 12 plus 5 is -7. Oh, I can see a 0 gets me -7 immediately. Let's see if a 0 gets me -7 here. 0 minus 2, -2 squared is 4. Yep. 5 minus 12, -7. Let's get another check on the test. All right, name that tune, I gotta put something down. Very important that we start to see how to write. Let's say we got 50 sheep in gill. And forever, there were always at least 50. And in 1905, there was a big jump in sheep to 57. Took a long time to get that improvement. And now we've got, in the year 2000, there was another jump, 64. All right, so what do we got? We got everything in this graph, all the y values, that y value, that y value, that y value, all the y values are bigger than 50. How much bigger, you ask? First one is 7. Oops, I don't need that in parentheses. That's 7. And then the next one is 14. Looks like the differentials are doubling. It's not 7, 14. In case those numbers aren't so nice the next time. Then I want t minus 1905. Highlighting. And 2000 is a jump of 95 years. And if I want to make sure this is right, I'm going to drop 2000 in. 2000 minus 1905 is 95. 95 divided by 95 is 1. 14 over 7 is 2 to the 1, so that's 2. 2 times 7, 14 plus 50, 64. All right, so now I want to graph the inverse. Well, I got a graph here. Why don't I just, the inverse of y equals 50 is x equals 50. And the inverse of 1905, 57 is 57, 1905. And the inverse of vertical jumps are horizontal jumps, 50 to 57, 7. Then the next one's going to be twice that, right? And the next one is 2064, so 64 to 2000. And you're getting something that looks like that. And that's still going to take some time to get a feeling for this trajectory. First year of study here. It's going to take us some time to digest that, but we got the semester. We'll do it every day. Hopefully it means more to you now than it did last week. All right, so what's the name of this? Well, let's do it using our inverse methodology. Let's pretend that our function, y negative 1, we'll use x, which means the input, output. Now the output becomes the input, which means I'm doing solving equations here. And if I had a y value, like, I don't know, let's go up, that was 14, let's go over 28. So 28 should get us 28 units, 14, 7, 50 plus 28 is 78. Right, so if this thing, if I wanted 78 as an answer, this is where I am, I'm over here, right? Well, what would be the first thing you'd do? I think I'd take my 78, this represents the number 78. I think I would subtract 50. I think I would divide by 7. I think I would log base 2. I think I would multiply by 95. And I think I would add 1905. That should get me 78. So if I put 78 in here, I should get the year adding 95, 2001. So adding, boy, I hope I'm not butchering this thing because I got lost in my thought process. All right, so let me make sure I'm doing this right. So 50, 57 got me 1905, I think. So I'm going from amount of sheep back to years, and the year 64 got me 2000. I just gotta make sure I didn't butcher something here talking too much. So let me just do this from scratch here. All right, so 1905 plus 95 log asymptote of 50, so x minus 50, so that was right. Drop in 57, that's right. And then drop in the year 64 or 64 sheep, which gets me base 2. Is that what I have down here? That was the original. I guess oh, here it is. So 95 log x minus 5. Okay, so I didn't say anything wrong, but I thought it was a very awkward explanation. And, we'll tackle it again in class. And at least you got a chance to, you can replay it, slow it down a little bit. Might have to on that one. Poor explanation on the old guy's part. All right, so I want to sketch this. I see cut shape up. I see a y-intercept of 5, 0 gets me 5. And I know that I'm on the decreasing side, so here's 0, 5. And if you want to know why I know that, you got to go back to one of the other videos because I explained it a couple of videos ago. And so now I just need minus b over 2 base, 16 over 8. Minus b, 2 times 4, 8, 2. And that's consistent. That's bigger than that number, so it's consistent. And then I got to drop a 2 in. If I drop a 2 in, I get 16 minus 32 plus 5. You can take more time with that. That's minus 16 plus 5. That's minus 11. All right. I can always look at minus 11 to 5, which is the jump of 16. And the quadratic change from 2 to 0 is 4, and 16 divided by 4 is 4. That's just a quick check. All right, I didn't make a mistake. Now I want to put it in graphing form. So graphing form. I can certainly take the adjuster. Then all I gotta do is work with the vertex. X minus 2 minus 11. Yep, then the smallest square that you can have is 0. 0 squared is 0. And this is a minimum at 2. So I want 2 to act like a 0. Oh yeah, 2 minus 2 acts like the old 0 squared. Was there anything else that I asked you to do? I'll find the roots. Okay, well, now that I don't need this for the roots. I don't need that. I don't need that. I don't need this. I do need 4. All right, so that x value, 2 plus or minus. Minus 11 goes up to a height of 0 somewhere, right? Y equals 0. I think that was 5. So a couple of places like that. So I got to go up 11 units. And I got to multiply by 4. So those were the roots. 2 plus or minus the square root of 11 over 4. So let me explain that because I probably did in class. Okay. First off, when I put the number minus 2 in here, minus 2 squared is 4. 4 times 4 is 16. 16 minus 11 is not 0. That number doesn't work. So does it make sense to put a 2 in here to get rid of it because it doesn't work? Now we have 4 times something squared that has to equal 11. Right? Because I'm really moving up 11 units. Well, it stands to reason that you only want 1/4 of that because you're going to multiply it by 4. Right? So that 4 would move over. And what squared equals 11/4? The square root of 11/4. And we got to do plus minus because we certainly know there are 2 sides, 2 quadratics, 2 parabolas, a positive answer and a negative, and we do not want to discriminate against the negative. Too long, discrimination for too many years, and it's going to change in this class. So there's a little explanation as to what's going on, but if it didn't make sense to you, we're going to talk about it again every day. So we got a vertex. We got a mechanical process, 1, 1, so x minus 1 squared plus 1. Highlight the vertex. Put a 5 in, get a 12 out. Put a 5 in right now, you get 16 plus 1. Put a 5 in, do the math, you get 16 plus 1. I don't think that's 12. So we get rid of that 16 units of change, and we want to change from 1 to 12, then you better go up 11. There's that quadratic. Play it again, Sam. Moving right along. Okay, we don't want to belabor anything at this stage. So this is already a quadratic right here. That's a product, right? What makes 0 squared? Putting in a 0. So this quadratic, 0, -7, we want to know when it hits a height of 25. Right? So there are real answers here. What's the first step? Add 7, 32. Divide by 2, 16. Take the square root with a plus minus. Those are the numbers that work. All right. 5x minus 3 squared. Hopefully you're just writing your answers at this stage. Hopefully you've done and thought about that enough as to where it came from. And if not, time to study a little harder. All right. Same thing here. Squaring the first term, 9a squared x to the 4th. Doubling the product, -2 times 3 times ax squared y to the 4th. And we've got 2 of those. So -6 becomes -12. Ax squared, y4. And then squaring the last term, 4y8. And about half the class at this stage usually knows how to do that, and half doesn't. Hopefully you're in the half that knows how. Working with the cube roots, 5m minus 4, recognizing 64 as 4 cubed. And then building the next parentheses off of the first. We got 1 dimension, we got to get to 3, we need the next 2. Hopefully that makes some sense. We got to get some cancellation here, so a minus becomes a plus, 20m. And it's just memorization of the process here. If you're thinking about it, you'll learn it. If you're not, you won't. And then squaring the last term. And that, when multiplied out, equals that. All right. So y equals 6. I've got a couple of coordinates. And I want to write the y values first, 6, 9, 18. Well, I already have a 6, so I'll leave that there. Looks like I got to add 3 to get to 9. Next time I don't add 3, I want to get to 18. 6 plus 12 gets me 18. That's the hard part. The easy part is seeing it's exponential, so I'm going to use t for time. T minus 1950 over 50 years. That's the change in time. There's your model. So it's real quick and easy to write exponential functions if you put the time and effort in to learn how. Plus, you get a right check on an answer key, which is going to make you feel better and make me feel better. Okay, replay it. Don't be afraid to replay anything and hear it again. I'm trying to get through it somewhat quickly. Oh my God, I just dropped the marker and I got ink on the floor. And they worked so hard to clean this floor. Let me get a little spray on that. If I did that. There we go. On there. Yep. All right, it came up. That's good. Where are we at? We're at conceptualization here. 8/27 to the -2/3. Well, you got 3 operations. I'm going to do the minus, which means flip. 27 over 8. And I still have to do the 2/3. I'm going to take the cube root. The cube root of 27 is 3. The cube root of 8 is 2. And then I'm going to square it. And I'm going to get 9 over 4. All right, we want to conceptualize at this point. What ties a 9 and a 3 together? Base 3. All right, so what do I have to do to a 9? I got to take a square root. Now, if you don't see that, then you have to go to mechanics. 9 to the x equals 3 to the 1. 9 is 3 squared to the x equals 3 to the 1. The multiplication rule, 2x equals 1, and therefore x is a half. All right, what number ties 16 and 1/8 together? Think a 2. So how do I turn the number 16 into a 2? I think a fourth root. All right, so now I take the fourth root of 16, it's a 2. How do I turn a 2 into a 1/8? -3. Okay, again, if you didn't understand conceptually, how do you do it mechanically? You start with the command. What do you put on top of 16? You get an 8. That's the language of this problem. That's the language. 16 is 2 to the 4 to the x equals 1/8, which I'm going to shortcut and say 2 to the -3 at this point. And so 4x equals -3. I hope you can see where -3/4 comes from now. We got another one. Practicing a lot of exponential activity here. What ties a 9 and a 27 together? Base 3. What do you have to do to turn a 9 into a 3? You got to take a square root. Now that you have a 3, what makes it a 27? Cubing it. All right, so that's conceptualization. Yeah, say you're having trouble with conceptualization. How do we get that 3 halves? Well, we do what's being asked. 9 to the what is 27? 9 is 3 to the 2x. 27 is 3 to the 3. And I hope you can see 2x equals 3, therefore 3 halves from a mechanical standpoint. All right, probably bit off a little too much here in terms of new material. I'll just do this one for you. So what I'm going to do is make a new coordinate system. I am going to do x minus 7 squared minus 49. That's another name for that. Check it out, think about it, do the binomial practice. This one is y minus 1 squared minus 1 equals 50. And so I'm going to add these numbers to the other side, and I'm going to get a Pythagorean relationship with x minus 7 as the base, y minus 1 as the height, and that's 100, so that's 10. So can you see x minus 7s? Can you see the Pythagorean theorem at work here? A squared plus b squared equals c squared. All right, so what's the origin? Well, 0, 0 really comes from 7, 1. Those are friendly numbers. What happens when I put a 7 in here? That goes. So I either get 11 or -9 here. So 7 gets me -11, or 7 gets me positive 11, or -9 also works. And so right now, if we have 7, 1, let's call that 7, 1, I've got 2 places here that work. I also could have put 1 into this equation for y. If I put 1 in, then I'm solving this. So I got to make that 10, 17 makes it 10, or -10, -3. -3 is over here, 17 is over here. We get a circular rotation. All I did was show it to you. I'm not expecting you to do that at all yet, but I am expecting you to replay what I just did. Think about it a little bit. Students generally have great success with this after a week of practice, maybe 2. And you haven't had that practice yet. All right, I will erase this on my own time after. I do need room here for these problems. All right, so have we learned what f of 5/9 means? F of 5/9 means I'm putting 5/9 into the f calculation. Minus 2/3, 5/9 plus 1. I expect you to get better with fractions. So therefore, minus 10/27. And I'll express the number 1 with a common denominator, 27. I guess it's 27. So what was f of 5/9? F of 5/9 was 17/27. So that one's done. Then we're going to do f of g of -2. I got to do g of -2. I got to put -2 into the g function. Minus 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. So now I'm doing f of 9. Okay, f of 9 is minus 2/3 times 9. Oh, that's nice. Nine's a multiple of 3 plus 1. 3 goes into 9 3 times, minus 2 times 3 plus 1, minus 5. So the answer to that's minus 5. Moving right along, so we don't get that nasty 10 minutes left on Zoom. I think we're coming in under 45 easily. The inverse of f, well, here's f, right? So I'm pretending that I'm solving for a y value. What I'm doing, pretending I'm solving for y. What do? I subtract 1. I multiply that by 3, a very big time algebra 1 concept. If you didn't put it in parentheses, you're wrong. And then dividing by -2, but never divide with a negative in the denominator, move it into the numerator. And that y value, we want to work in a calculator or a computer as a function, so we're going to put it in terms of x. That's the process. That's capturing all of the ways you would solve equations. So let's put a number in that's easy to work with. Let's make this a 3. Oh, we already did one, didn't we? I don't know what it was. Let's put a 3 here. 3 goes into 3 once, minus 2 plus 1 is -1. So in F, a 3 got us a -1. So what is the inverse going to be? The -1 is going to get us a 3. So I'll put -1 in, hope it works. -1 minus 1 is -2. 2 goes into -2, -1 times. And -1 times -3 is 3. I get another check on a test. All right, so we're talking bingo, bango, bongo over here. Hopefully we did that in class, but I'll do it again. So what are you supposed to do with these problems? You're supposed to multiply by 7/7. This is what you learned in grade school. And over here, 2 and a 2. That's what you learned in grade school. All right, so what do we have? We have 7 times 3. Are you telling me that we can't see 3 times 7 from the get-go? And the other one was 2 times 5, right? Can we not see that from just cross multiplying? And 14 is the there's your bingo, bango, bongo, right there. So bingo. Well, first off, if it's negative, then you put a negative between the parentheses, and you simply multiply top left times bottom right. There's 21. Then you multiply bottom left times top right. There's 10. And then you multiply across. There's 14. That's bingo, bango, bongo. And you can get a quick answer to fractions that way, 11/14. And that works for all numbers. So we're going to do it now, algebraic. But to do it, we're going to set up our little cement guidelines. Bingo, bango, bongo. And it's another multiplication with a subtraction here. So top left, x minus 2 times 5. I got to multiply both parts of that times 5. 5x minus 10. Then I got 3 times x plus 4. I got to multiply 3 times both parts. 3x plus 12. And then I got to multiply across 15. And 5x minus 3x is 2x. Minus 10 minus 12 is minus 22. And over 15. And now, first time I asked this on a test, I might have had one student get it right. So I think there's some real thinking that has to take place here and here. This will give that some thought. All right, we could easily check it with a number, but time won't permit right now. And if I had to pick a number, I think I would have picked, I don't know, what would have been easy? Maybe 5. You got 1 minus 9/5. Then to 3 divided by 3 is 1 minus 9/5, which is 5 minus 9/5. So minus 4/5. And putting in a 5 here. 10 minus 22 is minus 12 over 15. And if you put a 3 in, you get minus 4/5, which is the same thing as that. I mean, you can always check your statements with the number. That's what algebra is about. It's supposed to work for all numbers, then put a number in and see if it works. If it doesn't, you made a mistake. Yeah, we've been doing this problem for a while. Hopefully, we got some good tutors in the room. So what am I gonna do? I'm gonna multiply to get rid of a 4 and a 5. I'll pick 20. That's a multiple of 4. 4 goes into 25 of these things, so minus 5x. 20 times minus 4, minus 80. 5 is a multiple, 20 is a multiple of 5. 5 goes into 24, 4 of those 2 x's, 8x. 20 times 1 is 20. All right, I don't like to divide by negatives, so I'll bring this that way. 13x, I'll take 20 away from 80, minus 100, and I'll divide by 13. And there's your answer, and if you get it on a test, you get another one of those. The more of these things you get, the better your grade. The reason I'm doing these things with you, I don't want you doing a homework, ever doing a homework where you get a problem wrong. Because if you get it wrong, you're learning how to get something wrong. You're getting better at getting something wrong. All right, so I want everything that we do to be correct. Now, I'm gonna make mistakes occasionally, and you can blame me for that. But that's the idea here, making sure we get things right. Binomial squared, 49, double the product, minus 28i. Oh, I gotta double it. Here I am talking about making mistakes. Gotta double it. Product's minus 28, so minus 56. Squaring that, 16i squared. What does I squared do to positive 16? It makes it negative 16, and those are like terms now. Minus 56i, and that becomes what, 33 minus 56i. And I'm not going to spend a lot of time with that because by the end of the semester, everybody's going to be getting those right. And this is a marathon. 3i to the 19th, usually everybody gets these right by the end of the semester. Some people the last week, but hopefully it won't take you that long. So 3i squared, 9 times gets me to 18. I need one more multiplication of I to get me to. So I'm going to change the sign of this 9 times. If I change it once, it's negative 3 twice, positive 3, 3 times negative 3, 4 times positive. Should become negative 3 because I'm going to do it 9 times. Yeah, there it is, 9 times. Now, in not number, well, negative 1 once, negative, twice, it's positive, 3 times is negative, 4 times is positive, so on and so forth. Odd stays negative 1, minus 3i. Yeah, we're getting there. Getting there. A few more problems to do. Do I want to get this? All right, well, let's do these first, and then I'll readjust the camera. All right, 7x plus 2y equals 19. I put a 0 in, 19 halves. Put a 0 in, 19 sevenths. So we got something that looks like that. And it's going down. Because both x and y intercepts were positive. Okay, so our slope is going to be negative, and we can see our slope by just doing that. So y equals minus 7 over 2. Right? This number doesn't affect rates of change. So this is going down at 7 to 2. It doesn't look like it, but it is. And so therefore we got to go up. The reciprocal 2 sevenths. That's going to get us the perpendicular. I think it was check your answers. So x minus c plus a. I don't know how you check your answer here except doing a better job of graphing. Right? And I didn't really give you a point of reference, but maybe I should do a down 7. Let's call that down 7 over 2, maybe to here. It's about 2 to 7 ratio. Now we'll do the perpendicular. Perpendicular looks to be like that. And if I do where's the best way to do this? I guess here. Well, it took me a while. Does that look like it's up 2 over 7? Not the greatest drawing. So perpendicular would have been more like that. That would have been a better perpendicular. A 2 to 7 ratio. All right. Let's see, where are we at? Oh, sine, cosine, and tangent. X equals 3, y equals 7. No, we're going right back to the beginning of class. No, beginning of this worksheet. And so that means you've had enough time to forget that conversation. And now does the brain work hard enough to remember it? Well, I'm going to draw a picture. Pictures are worth 1,000 words. There's 3/7. Line now 9 and 49 is 58. So I know the Pythagoras square root of 58, and I'm drawing in standard position. So there's my angle. So what's the sine of angle A? 7 over root 58. What's the cosine of angle A? 3 over root 58. What's the tangent of angle A? Opposite over adjacent. 7 over 3. That's all that was. All righty. Oh, we'll do some graphing here. Where am I? Oh, 2x minus 3y equals. Notice how I said 2x minus 3y. I could have said 2 times x minus 3 times y equals 30. Why the word times is important? Because this is a product. If it's got 2 factors, 2 and x, those are its factors, 2 and x. And when we set a product to 0, we get quick information. So what makes that product 0? 0 does. And 0 is the y-axis. For x equals 0 is the y-axis. So all I have to do is solve that, and I get -10. So 0, -10, and we call this standard form. Standard form, you're using the x and y intercepts. And if you graph it any other way, then you do not understand the language of the way that's written. And I'm grading you on the language. If you change that to mx plus b, no credit in this class. All right, because the quickest way to graph this is to put your hand over that and solve that, -10. Put your hand over that, 15. So 15 is about 2/3 that way, so there's about 15. 15 gets us 0, and this is what I want to see with some arrows would be nice. The y-intercept and the x-intercept for something written in standard form. Boom, that has been discussed. Now, we want to graph another linear function. This is in point slope form. Point slope. Okay. So what's the point? Well, this is a product. What makes this product 0? -3. If you have -3 on the right side, you need, and it makes a 0, excuse me. You put -3 on the right side, it makes a 0 on the right. Then y plus 1 also has to equal 0 on the left. So -1 is the y. So you're supposed to see the coordinate -3, -1 coming out of this. In a lot of textbooks, this is the way this is written for most linear functions going forward, is point slope. I wish the positive one was written on this side, because I think that fits the format of quadratics in graphing form, cubics in graphing form, etc. But I think better than point slope is double point, because you know your x's are changing by 3, so that's going to be a 0 up 3. And you're also, your y values are going up to 0, 1. I think you're better off plotting -3, -1, and 0, 1. But if we hold to the name, I suppose we'd be at -3, 1, and we'd go up to over 3. I guess we would show this point -3, -1, up to over 3. That takes care of that one. I'm just doing that for my own benefit. Want to sketch -2x²? Well, then I know I got a cup shape down because it's negative. Positive tells me that the y-intercept 0, 5 is on the increasing side. I don't even have to care about the negative or positive b over 2a. All I gotta do is take b and divide it by twice this. 12 divided by 4 is 3. Right, because I know it's got to be to the right of 0. And if I put a 3 in, I get 36. Cut in half is 18. Add 5 is 23. And now I have the roots because I got -2. So I've got the -2, that's going to go here. And how do I get from 23 to 0? Here's a height of 0. I got to go down 23. A negative and a negative is positive. And I'm measuring from 3. So those are the roots of this. Why? Because we can show it -2 times that and plus 23. And we're going to show that that equals 0. We're going to use the vertex. So -3, right? So I put a 3. Right? Okay, so now I'm going to take this and plug it in. 3 plus or minus the square root of 23 halves. All right, well, first off, 3 minus 3 cancels. When you square a plus or a minus, you get a positive. When you square a square root, you get what's inside. When you double this and put a minus sign in front of it, you get -23 plus 23 is 0. And I hope that you're doing that on your own once in a while without me having to prompt you to check things, because that's where you really start to learn math, is when you play with the numbers. All right, so exponential growth, I have a doubling. So I'm going to pick a height and another height. That should be a good graph. This x value was 1999. And this x value is 23 years bigger, so 2022. All right, that's going to get a height of what and a height of what? Well, I know that my y asymptote is 11. And my first jump is going to be 3, so this is going to be a height of 14. And my next is going to be twice this jump. And 2 times 3 is 6. 6 plus 11 is 17. Right? And that's twice this jump. Okay, now, I hope you take the time to see that when you put 1999 in there, you've created something to the 0, which is 1. And then if you change it by 23 years to 2022, then you've got something to the 1, which is whatever's in the parentheses. That's what's going on. And I hope you take the time to do that, to actually put the numbers in there so you can see what's happening. Because if you can see what's happening, you have a better understanding of what's happening. All right, so what do I see? I see a negative square root. Well, square root is slow change, positive change. Putting a minus sign is going to make it go in the other direction. And square roots, they're the side of a square. And I can make that exceedingly small, as in 0, no length to the square. And I want the number 4 to make that happen. And if I put 4 in, I get 5. I'm a big fan of the square root of 25. So I'm going to put 29 in here. And then my brain can work. Ooh, wait a minute. Hi, this is not the typical question I usually ask. Okay, so I want to get rid of, I got to get multiples of the square root of 3. So for this particular problem, I got to get a multiple of the square root of 3. I think the easiest multiple is itself. So what can I do to make this the square root of 3? I'm picking 7. Okay. That cancels, and I get -2 plus 5 is 3. Now this is not a very nice one to find another value. This is not the nicest one. What would I find? I think the square root of, I think 4 root 3 maybe? Maybe 4 root 3? 4 root 3 minus 4? No, that's not, that's bad thought process on my part. I'm trying to think of what would be easy, because you don't know the square root of 3 yet, although I'm giving you out today, I think I'm giving you a sheet where it says the square root of 3 is approximately 1.73. We'll just leave it at these 2 points at this stage. And we'll try to tackle that after midterm. right? Because I think it would take some explanation on my part, and I don't want to spend that kind of time on it yet. All right, so E notation is 2.71 to the X, right? 2.71 to the X. All right, and so that's in between a doubling function and a tripling function, closer to the tripling function. But e to the 0 is certainly something that, anything to the 0 is 1. So we're going to work with making this 0. And on your sheet, e to the 1.1 is approximately 3. That's actually the number that's easiest to work with in terms of e notation. We create a tripling function. So I'm just going to show you at this point. We haven't done it much. Maybe we have. I don't know. These are all guesses on my part. Well, it's exponential growth. Okay. That's not hard to see. E to a positive x is exponential growth. The constant, we've been doing enough of these that we should be able to get there pretty easily. And we should be able to put a 3 in here and have some understanding of what's going on. That gets me, when I put a 3 in there, I get 2e to the 0 plus 5. Anything to the 0 is 1, so we get a jump of 2. That's our first jump. Right? And that gets me to 3 gets me 7 in this equation. I think we can see that. Now, what I really want is 2, so 2. E to the 1.1 plus 5, because that's approximately 3, which means that this is approximately 11. All right, and if I'm tripling this 2, I would say that's a pretty good estimate of tripling. All right, so the only thing I have to do is make x minus 3 over 4 equal to 1.1, and then I can do this. That's not hard. So x minus 3 equals 4.4. Adding 3 gets me 7.4. So that's this point, 7.4 gets me 6 and 5 is 11. Now I already have a video made of about 5 problems in a row, and that'll probably be your next homework, graphing e to the x. And got to get started with more examples than just this one. So I think I call it rapid fire 5 as a process. Start with one, I do it with you, you watch, give you another one like it, pause the video, I do it again. By the time people get to the 5th, there's usually some learning, some serious learning taking place. So we're going to get to that momentarily, but not today. And the brakes will be on here. Give you a chance to pick up as many of these calculations as is possible. All right, so now we have the inverse, and it's a negative. Oh, this is a tough one. I shouldn't have done this, but I'll just show you. All right, so the first thing we do is we build the asymptote, x equals 3, because these are all the quantities from growth and decay. And if we don't have a positive quantity, we can't talk about it growing or decaying. And this is going backwards from time. So this y value is really our times. And the quantities came at what time? All right, so what do I see? Well, I know that e to the 0 equals 1. If that's true, then the ln of 1 equals 0. And I know e to the 1.1 is approximately 3, then I know that the ln of 3 is approximately 1.1. It can take a while to make that just, fluency. Fluency here is going to take a while, which is why we're tackling it early in the term, because, honestly, I do math help, used to do math help here most nights, and I don't care what level came in, could have been beyond BC calculus. Wasn't understood. Okay, some very bright students, but asked them what a logarithm was, and you wouldn't get an articulate answer, let alone any kind of semblance of an answer. Generally speaking, you wouldn't get any kind of this is what a logarithm is. Okay, so that's why we're tackling it so early. All right, so I want to make x minus 3 equals 0. I want x minus 3 to equal 1, and I want x minus 3 to equal 3. Those are going to be the friendly LNs. The ln of 0, we've had a few worksheets, that's got to be positive. What makes x minus 3 positive? 3. So our graph's going to be on this side. What makes this a 1? A 4. I'm going to put it here because I'm pretty sure I know what I'm looking at. So what is the ln of 1? You got to keep hearing that. It's 0. Why? Because you put 0 on top of e to get a 1. All right. So if that's a product and I make a 0, 0 times -2 is 0 plus 4. A 4 gets us a 4. Hope you take a little more time with that to see why that becomes that. Think about it. And then I also want x minus 3 to equal 3. And so that's 6. All right. So if I put a 6 in here, 6 minus 3 is 3. ln of 3 is 1.1. I'm going to multiply that times -2, and I'm going to add 4. That's minus 2.2 plus 4, which I believe is 1.8. 1.8 is smaller than 4, and 6 is bigger. So 6 gets us 1.8 roughly. And so that is your trajectory. Right. Now, what number would have been nice also to work with? 3.5. 3.5 minus 3. Let me do 3 1/3. 3 1/3 minus 3 is a third. ln are exponents. I just flipped, which means this is -1.1, which means I'm adding 2.2, which means I'm up here somewhere. 3.5 gets me approximately 6.2. Now, I hope you can see the trajectory here. And the last problem, I'm not even going to do 39. I think we've been at this too long. Save that for another time. All right. Otherwise, you're probably comatose at this stage. All right, but it's all good for you. I don't know how many of you are hanging in there and seeing the whole video and following it. If you are, it's going to benefit you greatly. I mean, the more reps you get, the more considerations you do, just like anything else in life, the more foul shots you take, better your foul shooting in basketball, any kind of skill. And half of what we're doing is skill, the other half is probably concept. All right, so where's the concept understanding come from? Keep talking about it, keep talking about it, keep talking about it until you make the connections. All right, and everybody learns at different speeds. All right. See you in class tomorrow.